The James Webb Telescope has recently sent a dazzling message that has left all NASA scientists amazed. As the greatest optical telescope in space, it has been observing different parts of our gigantic universe for a seriously prolonged stretch of time, uncovering various eccentricities. However, the new picture it has sent has created a wave through the world of science and astronomy. What startling image has the James Webb Telescope captured? Could it have photographed an extraterrestrial spacecraft in the farthest reaches of space? Join us as we explore the alarming new images that the James Webb Telescope has unveiled, images we have never seen before. If you're excited about staying completely informed about news from the universe and its ecological elements, subscribe to our channel, like this video, and turn on notifications. NASA's $10 billion James Webb Space Telescope was launched from the European spaceport in French Guiana. When it arrived at its new grand home, this infrared observatory provided dazzling views of the universe to analysts and stargazers. As the greatest and most advanced space telescope to date, analysts were excited to see the first scientific pictures captured by the telescope. What they saw nearly left them frozen. When the James Webb turned its instruments toward the well-known pillars of creation, it captured the famous dust clouds in great detail. These pillars are located in the constellation Serpens, around 7,000 light-years from Earth. The pillars of creation are part of the Eagle Nebula, massive clouds of gas and dust that were first imaged by the Hubble Space Telescope in 1995. Since then, the brilliant glow of the pillars has been revealed. The new photograph captured by the James Webb Space Telescope uncovers the pillars of creation in even more critical detail. Some stars are visible that were not found in the previous image captured by Hubble, some of which formed 2 or 3 years ago. This represents a significant scientific advancement. The James Webb Space Telescope has also examined the so-called Pandora's Cluster in a stunning image named following Greek mythology. Pandora's Cluster is a region predicted by Albert Einstein in 1915. These new pictures astonish scientists as they reveal details previously unknown in this region of space. However, it is important to note that this area of space has a formal name, known as a 2744, which is part of the Pandora cluster. This cluster houses a combination of distinctive structures within it. What is so captivating about this image is that it's been seen before, but only the central part of space has been examined by the Hubble Space Telescope. This suggests that various cosmic secrets still need to be discovered in this fascinating region of space. Until the James Webb directed its powerful infrared instrument to the area to observe the Pandora cluster, the observing team used the large telescope's near-infrared spectrograph and near-infrared camera as part of the deep observation program. Before the ionization epoch images were taken and then combined into a panoramic image, this panoramic image revealed around 5,000 infrared light sources in the Pandora cluster, which is about 3.5 billion light-years away. The image captured by the James Webb Telescope achieved an extraordinary concordance between depth and breadth, which could change our view of cosmic evolution. A highlight of the image is a bright foreground star in the Milky Way, whose remarkable diffraction pattern was created by the James Webb Space Telescope. Also visible are brilliant sources of white light surrounded by a hazy glow corresponding to much more distant galaxies within the Pandora cluster. Although human-made technology is essential to the observation of this galaxy cluster, astronomers also relied on a natural phenomenon proposed by Albert Einstein in his theory of gravity, known as general relativity, published in 1915. Additionally, intriguing discoveries continue to excite scientists and space experts. The James Webb Telescope has captured peculiar cosmic phenomena that even experts cannot fully explain. One such mystery is the baffling concentric rings found around a distant star, which still cannot be completely understood by space experts. The image was posted on Twitter by a citizen scientist, sparking a storm of comments and debate among the online community. The picture showed a star called WR-140 surrounded by regular wave-like circles that gradually faded. What was striking was that the circles were not perfectly round but had a somewhat square appearance. This immediately led to speculation about a potential extraterrestrial origin. However, some analysts argued that it was simply nature performing something that appeared extraordinary when viewed from a single perspective. Sometimes, natural phenomena might seem spectacular from certain viewpoints but have simple explanations. Nevertheless, questions remain. Why do they have that specific shape and why are they so regular? These questions have troubled experts like Mark McCann, an interdisciplinary researcher with the JWST Science Working Group and a science advisor to the European Space Agency, who called it surprising. In a Twitter thread, he explained that the sharp blue pattern is an artifact due to optical diffraction from the bright star WR140 in the image. Nonetheless, he noted that the red bend is real and represents a series of shells around WR140 in space. Despite the fact that NASA is expected to provide an explanation soon, young stars generally tend to shine bright blue, while over time they take on a redder glow as they burn their fuel and cool. Cosmologists did not expect to see old red stars in the early universe for which the James Webb Space Telescope was designed, nor did they expect to see galaxies up to 1 billion times more massive than the Sun. These red spots revealed in the images captured by the James Webb Space Telescope appear to be many times more massive. According to Jan K., the most massive galaxies in our sample are estimated to have masses between 2 and 4 times less than that of the Milky Way. She said this discovery is astounding since galaxies as large as our own were found when the universe was only 3% of its current age. Leah also mentioned that before cosmologists start adjusting cosmological theories to explain how these galaxies formed so quickly after the Big Bang, they will need to ensure that the peculiar red spots they are observing are not something else. Nonetheless, alternative explanations would also require entirely new ideas. For example, stars in the early universe could emit light in unusual ways due to a lack of heavy elements not included in our models. The images that revealed these mysterious galaxies were obtained by Webb's near-infrared camera as part of the Cosmic Evolution Early Release Science program. The team plans to return soon to these galaxies and the SMACS 0723 cluster to obtain spectra of light from distant sources. The spectra decompose the observed light according to its composition into frequencies, thereby revealing the chemical and physical properties of its source. Notably, the spectra provide very accurate distances to these objects. The distance and nature of these objects are interconnected, and if we know the distance, we can pinpoint their characteristics. Leah states that just a few months after Webb's team released the initial observations, scientists are being forced to revise theories about the early universe. Observing the early universe for the first time led us to discover something so astounding that it poses problems for science overall as it challenges the entire picture of early galaxy formation. Another astounding image captured by the James Webb Space Telescope shows the Ghost Galaxy, which looks like a whirlpool turning before our eyes. This new image, based on deep space data, highlights the dust lanes of the galaxy NGC 6208, or M74, also known as the perfect spiral due to its symmetry. The Ghost Galaxy is interesting from a scientific perspective because of the intermediate mass black hole that scientists believe is at its center. Although the Ghost Galaxy has been imaged several times, including by space observatories like the Hubble Space Telescope and the Spitzer Space Telescope, Webb's images stand out due to the near-infrared light that revealed vast dust combined with the power of its unique 18-segment hexagonal mirror. The James Webb Space Telescope, hailed as one of the most ambitious endeavors in space exploration, continues to amaze scientists with its exceptional capabilities and discoveries. Launched with a mission to uncover the deepest secrets of the universe, Webb has not disappointed in its initial observations. From capturing the intricate details of distant worlds to revealing previously hidden phenomena, Webb's contributions to space science are rewriting the textbooks of our understanding. One of the telescope's remarkable achievements is its ability to peer further into space than any other instrument before it. By harnessing its advanced infrared technology and utilizing a large 18-segment mirror, Webb has opened a new realm of exploration. Unlike its predecessor, the Hubble Space Telescope, which primarily operated in the visible and ultraviolet spectrum, Webb's infrared capabilities allow it to penetrate cosmic dust and observe celestial objects hidden from optical telescopes. This ability has proven crucial in its observations of the iconic pillars of creation within the Eagle Nebula. Webb's infrared gaze uncovered unprecedented details of these enormous columns of gas and dust, where new stars are born. The telescope's ability to see through the thick nebular material provided astronomers with clearer insights into the processes of stellar birth and evolution. Additionally, Webb's observations of galaxy clusters like a 2744 and Pandora's cluster have shed new light on the large-scale structure of the universe. By capturing thousands of infrared sources within these clusters, Webb has enabled astronomers to study the formation and evolution of galaxies across cosmic time. The deep-field images obtained by Webb not only expand our understanding of galaxy cluster dynamics, but also challenge existing models of cosmic structure and evolution. One of the most intriguing discoveries made by Webb is the presence of ancient galaxies that defy conventional cosmological theories. These galaxies, observed when the universe was only a fraction of its current age, have masses that rival or exceed that of the Milky Way. Such findings raise fundamental questions about how galaxies assembled and grew in the early universe. The James Webb Space Telescope, JWST, has rapidly become a centerpiece of astronomical research, significantly advancing our understanding of the cosmos. One of its most notable achievements is its ability to capture light from some of the earliest galaxies in the universe. This capability is rooted in Webb's advanced infrared technology, which allows it to observe celestial objects that are too faint or distant for other telescopes. Webb's observations have revealed new insights into the formation and evolution of these ancient galaxies, providing a deeper understanding of the early universe. Recent images from Webb have shown galaxies in various stages of formation and evolution. For instance, Webb has captured intricate details of early galaxy mergers, where two or more galaxies collide and interact. These mergers are critical events in the life cycle of galaxies, influencing their structure and star formation rates. The telescope's detailed observations of these processes are helping scientists piece together the history of galaxy formation, offering a glimpse into how galaxies like our own Milky Way may have evolved over billions of years. In addition to its observations of distant galaxies, Webb has also focused on nearby celestial objects such as star-forming regions within our own galaxy. The telescope's ability to see through dense cosmic dust has allowed astronomers to study the birth and development of stars in unprecedented detail. For example, Webb has provided new views of regions like the Orion Nebula, one of the closest and most active star-forming regions to Earth. These observations are helping scientists understand the complex processes involved in stellar birth and the formation of planetary systems. Another significant area of research enabled by Webb is the study of exoplanets. The telescope's infrared capabilities are particularly suited for analyzing the atmospheres of exoplanets, allowing scientists to detect and characterize their compositions. Webb has already begun to investigate the atmospheres of several exoplanets, providing data on their temperature, atmospheric composition, and even potential signs of habitability. This information is crucial for identifying planets that might support life and understanding the conditions that prevail on distant worlds. Webb's contributions to planetary science extend beyond exoplanets. The telescope has also examined our own solar system, including planets, moons, and other small bodies. For instance, Webb has observed the ice giant Uranus, providing new insights into its atmospheric composition and weather patterns. The telescope's observations of distant comets and asteroids are also helping scientists understand the early solar system's conditions and the formation of these small celestial bodies. The telescope's observations have also led to significant discoveries about cosmic phenomena, such as dark matter and dark energy. While these mysterious components of the universe remain elusive, Webb's detailed images of galaxy clusters and large-scale structures provide valuable data that can help scientists infer their properties. By studying how galaxies and clusters interact and evolve, astronomers hope to gain a better understanding of the role dark matter and dark energy play in the universe's structure and expansion. Webb's deep field observations are particularly noteworthy. These observations involve looking at a small, seemingly empty patch of sky for extended periods, capturing faint and distant objects that are otherwise too dim to detect. Such observations have revealed a wealth of information about the early universe, including the formation of the first galaxies and the development of cosmic structures. These deep-field images are not only a testament to Webb's observational capabilities, but also a window into the universe's past. The James Webb Space Telescope has also made significant strides in studying cosmic dust. Cosmic dust plays a crucial role in the formation of stars and planets, and understanding its properties is essential for comprehending various astrophysical processes. Webb's ability to observe dust in high resolution has provided new insights into its composition and distribution, shedding light on how it influences the formation of celestial objects. In terms of technological advancements, Webb represents a significant leap forward from its predecessors. Its large segmented mirror allows it to collect more light and achieve higher resolution images than any other telescope. Additionally, its advanced instruments, including the near-infrared camera, NIRCam, and the mid-infrared instrument, MIRI, are designed to work together to cover a wide range of wavelengths, providing a comprehensive view of the universe. The telescope's mission is not only to observe but also to help answer some of the most fundamental questions in astronomy. For instance, one of its key goals is to investigate the origins of galaxies, stars, and planetary systems. By observing the universe in its infancy, Webb aims to provide answers to questions about how the first stars and galaxies formed and how they evolved into the structures we see today. The James Webb Space Telescope has already made a profound impact on the field of astronomy, and its mission is expected to continue yielding groundbreaking discoveries for years to come. As scientists delve deeper into the data provided by Webb, they will uncover new aspects of the universe, challenging existing theories and refining our understanding of cosmic processes. The telescope's contributions will undoubtedly shape the future of astronomical research and expand our knowledge of the universe in ways that were previously unimaginable.